Hi everyone, it's Mrs. C. I miss you all a lot. So this is basically how the next couple of weeks are going to go with our learning goals here. I'm going to post videos, specifically 3 lessons, so 3 videos every week. And I'm going to be following our notes that you have on Google Classroom. So you can feel free to either copy them out with pen and paper or print them off and fill them in. That's okay. So I'm going to go through and I'm going to fill these in. I know that you can't see my face, but you can hear my voice, and I'll write stuff on the iPad. And then there will be some sort of work to kind of do so that you are fulfilling that 3 hours a week. Some of you might finish this really, really early, so it might not take you 3 hours. And I'm hoping that nobody will take longer than 3 hours, okay? The goal is that at the end of the week, you will be kind of forced. So I'm forcing you guys to each check in with me. So I should be getting at least 30 emails from grade 10 science class every week letting me know where you stand with what we learned. Okay, so before March break and before all of this craziness kind of happened, we were talking about chemistry and we were talking about chemical equations and balancing them and everything. And we talked about this idea that energy can't be created or destroyed, and neither can mass. And so we talked about the idea of conservation of mass theory and how everything works. So today, specifically right now, we're going to talk about how these chemicals actually come together to form bonds and to form compounds. So if you're looking here, I have elements kind of all over the place. I remember that these are called my reactants. So these things, if I'm adding them on this side, these are my reactants. And whatever I get over here, these are going to be my products. So I want to know kind of how my elements will come together to form products. And in order to do that, we can actually predict these chemical reactions. So chemists, including you guys as grade 10 science students, we can predict what's going to happen based on 5 general types of chemical reactions. And the first one is called a synthesis reaction. So synthesis happens all the time. We can do it organically or we can do it in a lab. And synthesis just means that we are making something. Making a compound. Okay, so we're making something here. So in a synthesis reaction, this is the easiest one to learn. This is exactly what's going to happen. So in a synthesis reaction, I have my two reactants. So I have my 2 reactants. They're going to form together to make one compound. Okay, and again, remember these are my reactant. Forgot to switch it. All having a learning curve here. So these are my reactants. And these are my products. My 2 reactants pushed together to make one product, okay? So here I have aluminum and oxygen. Notice that my aluminum is a solid, my oxygen is a gas. We'll learn about these things and how they kind of are most common, what forms they're most common in. So here, my whole goal here for today, I want you guys just to be focusing on trying to make skeleton equations. And remember, a skeleton equation means it is not balanced. So let's work on making skeleton equations and then we'll put everything together. So here I have aluminum and oxygen, and I said that basically my formula is that I'm going to take my 2 reactants and I'm going to push them together to make one product. So I'm just going to have aluminum oxide. And remember, I said that this isn't balanced yet. That's okay. But I do need to work on, so this isn't right yet. This is wrong. This is sad science face. Remember, I do need to work on my electrons and how they fill up those valence shells. So I'm going to have to do my crisscross rule. Okay, so I have aluminum and oxygen, and we need to think about what charge these things have. So if you're looking at a periodic table, you're going to remember that aluminum has a charge of 3 positive, oxygen has a charge of 2 negative. I'm going to do my crisscross so that this is actually going to equal Al2, because that 2 comes down here, right? This 2 is going to drop down, O3. Okay? All right, now I'm happy. And this isn't balanced yet. That's okay. I know that it's not balanced. That's okay. So here, now let's look at this. So I have hydrogen and bromine. So I'm going to do the same thing, okay, with my hydrogen and my bromine. Let's just zoom this in just a touch. Okay. All right. So my hydrogen and my bromine are going to form together in a synthesis reaction, and I'm going to be stuck with or left with hydrogen bromide. That's okay. Again, I need to do my crisscross method. So this is 1, hydrogen has a charge of 1. Bromine, on the other hand, is going to have a charge of -1. So I'm going to crisscross them down. Oh, look, this actually works out really well. It's just going to be HBr. Okay, now I'm happy. Okay, and again, if you don't remember how to find these charges, it's using that periodic table. Send me an email. I can do a different video if you need it. Okay, so let's move down to one more slide here. Okay, so now I'm just going to look at my last example here. I have nitrogen and hydrogen. Those are going to form together. They're going to make, well, we usually actually write this first, sorry. So we're going to have like this, hydrogen nitride. And so what I'm going to look at here, or sorry, let's just do it the way that you're used to seeing it. That's fine. So we're going to have our nitrogen and our hydrogen here. My hydrogen has a +1 charge here. My nitrogen is going to have a 3 negative charge. And this is going to make N1H3. And I don't need to have that 1 there. Remember that that's just an invisible 1. I'm going to erase that, but just so that you guys can see. This is a super important atom that we kind of learn about in biology, so keep that in the back of your mind. Okay, so this is a synthesis reaction. So in a synthesis reaction, I'm going to come together. I have my 2 reactants, A and B, and they're going to yield just A and B pushed together, 1 compound. So I start with 2 things, I end with 1. Okay, my next reaction here is going to be what we call a decomposition reaction. So if synthesis is putting things together and making something, decomposition is the exact opposite. So this is the opposite of synthesis. Okay, so what this means is that we're actually going to be breaking apart. We start big and small. Okay, so notice that I start with a compound in my reactant. So this is a compound here, and I'm breaking it down into its individual elements. So my products are going to be elements here. Okay, so I start with a compound in my reactants, and then I get to elements in my products. Okay, so I'm breaking everything down here. Basically what's going to happen here is that single compound is going to be broken down into 2 or more simpler products. Okay, so I'm breaking everything down into simple products here. In binary compounds, what will happen is that they're going to decompose simply into their elements. Remember, binary is just a fancy word for something that has 2. So 2 element compounds. Okay, bi means 2. So here, if I'm looking at HGO, this is actually going to be mercury oxide. Okay, so Hg is mercury. So here, I'm simply going to break them apart into their pieces. So I'm going to end up with Hg plus O. So a couple things to notice. This plus sign here is super important. This tells me that this is no longer a compound. So this plus sign, its whole job is to tell us that this isn't a compound. And rather, I'm dealing with 2 separate things. And in fact, 2 separate elements, okay? So again, we're going to start with the 2 easiest, right? So we started with synthesis where we're building up. Now in decomposition, we're going to be building down, okay? So if I'm looking at this, I have potassium oxide next. So again, I'm going to do the same thing. I'm going to break down my potassium. Okay, I don't need to put the 2 because potassium is not A diatomic molecule, oh, what did you notice that I just did? So I just noticed that. My oxygen is a diatomic molecule. It's part of that 7. So you start at 7 and make a 7 down to oxygen. So that should be, or sorry, to iodine. So that should be a 2 right there. Okay, so let's go back to this. So potassium oxide. Potassium is not a diatomic molecule. So I'm going to break it apart. So potassium, I'm going to put in my plus sign. I'm going to have my oxygen. And we just said that that's a diatomic molecule. So there needs to be 2 of those. Okay. So again, let's go back down to sodium bromide. So I have my sodium, break it apart with that plus sign, leave my bromine. Okay? And bromine is a part of the diatomic molecule. I'm going to throw in that too. All right? Okay. So this is decomposition. So I have synthesis where I'm building it together, starting with 2 separate things, going to end with 1 compound. Decomposition, I'm starting with 1 compound and I'm ending with 2 elements. And so now let's look at some things that get a little bit more complex. I mean, we've seen chemical reactions so far in this course that have to do with more than 2 elements. So that's what we're going to kind of look at here. So the next ones that we're going to talk about are called single displacement reactions. And let's talk about what this word displacement means. It means that we're actually going to go in and we're going to switch some things around. So really displacement, I want you to think single switching reactions. Okay, so we're switching. Okay, so here if I'm looking at this, it says A plus BC equals B plus AC. So really what's happened here, well, my A and my B have just switched places, so this is why I call it switching. Okay. So in single displacement reactions, one element is going to take the place of another element when we make those compounds. So here, if I was looking at my reactants here, A is an element, BC is a compound, but when I get to my products, B is now the element and AC is the compound. Okay, so I'm switching things around. In order to make a prediction about which element is going to displace, we use something called the activity series. And you guys used an activity series last year in grade 9 when we were talking about static electricity. Okay, so you would have used an activity series there to see how electrons moved between different things when we were talking about static electricity. The same idea here. So the higher the element on the activity series, the more likely it is to displace. So a metal can displace any metal below it in the activity series. So for instance, lithium here, lithium can literally displace any of these because every other metal is below it, okay? But if I was looking at gold, well, gold isn't going to trump anything. It's at the bottom of the tier. So basically, when I'm looking at this, as I move down the activity series, I'm losing my ability to displace, okay? So here, this is kind of like the king at the top, and then you go all the way down, okay? So again, we're going to use the activity series here to predict how this works. And I know what you're thinking right now. You're thinking, but Miss Cox, if I'm doing a single displacement reaction, only one thing is switching. And you're right, that is true, but we're going to move on so that 2 things are switching. So we're going to use the activity series. I've put the activity series right here so that you guys can look at it. So first thing I'm going to do is I'm going to find zinc. So I find zinc on my activity series. It's right here, okay? And the next thing I'm going to look at is my hydrochloric acid here, my HCl. Okay, so hydrogen and chlorine. If I'm looking at my periodic table, I know that hydrogen here is the one that's going to act like the metal, so I need to find that on my activity series. It's right here. Okay. Now zinc is higher than hydrogen, so what that means is that my zinc and my hydrogen are going to switch. Oops, again. Sorry, I forgot to switch it back to the pencil. Okay, so my zinc and my hydrogen are going to switch. So what that means in my products is that I'm going to have my hydrogen. It's diatomic, it has to be 2, plus my zinc. and my chlorine. Same thing is going to happen here. So I know that my hydrogen is happy right now. It's in its pair. But I need to figure out how many of these I need to use, okay? So chlorine has a charge of -1, okay? And zinc can have a couple of different charges here. So this is, again, where you're going to pull up your periodic table. So if I pull up my periodic table, even though zinc is in that transitional metals, it will only have one charge, and it's the most common charge, which is 2 positive. Okay, so 2 positive. So when I rewrite this here, I have H2 plus zinc chlorine 2. Okay. Okay, so my next one is tin plus sodium nitride. So if I'm looking at this, I notice that I have a couple of different things here now. Just so that you guys don't freak out, because I know that in my second compound here, I actually have 3 elements. Remember that, and you can feel free to do this, when you see these special ones that we were talking about before, you can throw brackets around so that you know that really that's one type of element that's kind of coming together as a pair. Okay, that's okay. So here, let me erase my side here. I have tin, like we said, so let's kind of highlight our tin here. And then I have sodium, which is going to be my element that I can talk about, okay? Because if I'm looking at here, nitrogen and oxygen, those are not on here. So if I'm looking at this, my sodium is actually going to be higher than my tin on my activity series. And what that means is that my sodium is so happy right here that it's not going to want to budge. It doesn't want to switch out with tin. There's not enough power or reactivity there. So what's going to happen is that this actually would be no reaction. Okay, that's not going to happen there. So again, let's go on to the next one. Why is this not erasing? Cool. Okay, cool. No worries. We'll deal with it. So if I'm looking at copper and silver nitride, again, we're going to do the same thing. So I want to find my copper, and I'm going to find my silver. Okay, so because copper is above silver, it has enough reactivity that it's going to switch. Okay, so now I'm going to have my silver plus copper. And again, we're going to have to kind of come up with our charges here. Now remember, copper can have more than one charge. So what I'm going to do here is refer back to my periodic table. So remember from before the break that nitrate, NO3, has a charge of -1. Okay, so I also know that my silver here had a charge of -1 because when I put these together, so on this side, when I put these together, there was no subscripts here. Okay, so that meant that here I was using my nitrate that had a charge of -1. So what I'm going to do here is the same thing. So it's going to have a 1 down here, and I'm going to use the most common charge of copper, which we know is going to be 2. Okay, so the most common charge. It's the charge that you see the most common on your periodic table, the one that comes first. Okay, so if this was a 1 here, then this is going to be a 2 out here. So this is how the activity series works. You're going to work through here. I want you guys to try to do the next 2 examples and see if this reaction is going to be a yes or a no reaction. That's today's lesson. So I'm already at 20 minutes. I don't really want this to be a long thing. I'm going to assign some reading in the textbook to talk about the double displacement reaction, and then I'm going to do more talking about that tomorrow, as well as some practice problems. So this is today's lesson. Send me some emails if you have any questions. Please feel free to pause, go back, listen again. This is going to be kind of, we're wrapping up chemistry here, and then we're going to do biology, which I think is a little bit easier to kind of do without being face-to-face. I'm still around for lots of extra help. Send me emails. I can make different videos, okay? Make sure that you go through and you remember how to do the crisscross rule. So remember that this here, this is all that crisscross rule or crossover rule. So please go through and talk about that and just go through your notes and make sure that you understand that and where we get our charges from our periodic table, okay? Our ionic charges. All right. So let me know if you have any questions. And like I said, I'm here. So shoot me an email. Have a great day, guys.